This next example is going to be us working through a stoichiometry problem, but we're also going to be incorporating molarity in as well. So now that you know how to work with molarity and convert from moles to liters and vice versa, you also have to be able to use molarity at any time during a stoichiometry problem. So for example, in this problem, we have 1 gram of aluminum reacting with 75 milliliters of 0.3 molar zinc iodide solution. Wants to know how many grams of zinc are produced. Now notice, based on this balanced equation, not everything is in solution. So we're actually combining two different things. We're going to pull some information in from chapter 3 as well as some information in from chapter 4 to work through this problem. So what I gave you already was the balanced molecular equation for this example. So we have aluminum solid, right? Aluminum is a metal, it's a solid. We have that reacting with the zinc iodide solution to form aluminum iodide, which is solution, plus zinc solid. So as we work through this, what we're going to be doing is using some stoich. So time to work through some stoichiometry. Now if you look at the problem, you were given amounts for aluminum, which was a reactant, as well as amounts for the zinc iodide, which was also a reactant. So you have an amount for each reactant, which means you have to figure out which one is limiting and which one is excess before you can work through the stoichiometry problem. So what I have set up is our given information for our aluminum, which is grams, and I went to moles. Remember, whenever you're doing stoichiometry, you have to convert to moles. So I went from grams to moles of aluminum, and I got 0.03706 moles. Then I did the same thing for the zinc iodide, but I was given volume and molarity. So what I actually can do is use the volume and use the molarity that we were given in order to find moles. So that's what I did with this zinc iodide, and I found 0.0225 moles of the zinc iodide solution. So now I have moles of both reactants. I have moles of aluminum, I have moles of zinc iodide. What we're going to do now is look at the mole ratio. If we look at the mole ratio from the balanced equation, we need 1.5 as much zinc iodide as aluminum. So it's a 3:2 ratio of zinc iodide to aluminum. So we need 1.5 times as much zinc iodide, but we don't have that. If we look at our amounts here, we have less zinc iodide than aluminum, and from the balanced equation we need more. So what that means is this zinc iodide is my limiting reactant. The aluminum is my excess. So let's change this to a star. So my limiting reactant is zinc iodide, my excess is aluminum. Now, we also could have set this up as a BCA table, right? Just like we've been working through some of the other examples, we could have done a BCA table here. I'm just showing you the different ways that we can go through this problem. So we now have determined that our zinc iodide is our limiting reactant, which means that is the amount, and that's what we have to use to determine how much product is formed. Because this question wants to know how much zinc we can form from this reaction. So now we have to use our limiting reactant. So I'm just going to start with my moles of zinc iodide because I already calculated that. I have moles of zinc iodide. I somehow need to get just to zinc. So this is where it comes back to the balanced equation. So if you look on your notes page, you have the balanced equation already. I use the mole ratio to go from zinc iodide to zinc. Right? In order to go from one substance to another, you only can use the mole ratio, and that's why you always have to convert to moles. So my moles of zinc iodide have canceled. Now I'm at moles of zinc. The problem though asked for grams. So what I'm going to do now is cancel out my moles of zinc by using the molar mass to get to grams. So again, to summarize what I did in this, I started with the limiting reactant, I used the mole ratio to get to zinc, then I used the molar mass of zinc to get to grams. And what you find is that you form 1.47 grams of zinc.